Good morning, students. So, in the subject Introduction to MEMS, chapter number 3, Review of Basic MEMS Fabrication. I am Madhuri Mulik, working as Assistant Professor in Department of Electronics and Telecommunication, Sharad Institute of Technology, College of Engineering. So, last time we have started the chapter number 3. So, just we are going to take one review of the previous session. So, deposition techniques in MEMS, we have started the first point from the chapter number 3. So, after that we have seen one example of MEMS pressure sensor where the deposition on the thin film of silicon nitride. Then we have seen what is mean by deposition. Then what is the purpose of the deposition layer. Then we have seen the types of layers for MEMS. So in that structural layer, sacrificial layer, conductive layer, insulating layer, protective layer, each stop layer and each mask layer. Then after that we have seen types of films. So there are different types of films and its various applications we have listed here. Then we have seen one example of MEMS deposition process, which is nothing but the 4 layers micro cantilever sensor. Then after that we have seen the types of deposition process. So in that last time we have covered spin-on film, thermal oxidation, chemical vapor deposition. So now in this session we are going to see the physical vapor deposition. So let us look on these three. So spin-on film deposition, where the spin speedy rotation and where liquid is placed there. So film is deposited. Then thermal oxidation process we have seen. So this is nothing but the thermal oxidation. Then in furnace, thermal oxidation, how it will be, we have seen. Then what are the steps involved in the thermal deposition process we have seen. Then we have seen the chemical vapor deposition. So in a chemical vapor deposition, again there is a two types, homogeneous reaction and that the heterogeneous. So name itself indicating that the gas phase. So reaction occurs before the gas molecules reach the vapor surface, and surface phase, that is reaction occurs as the reactant gases reach the heated substrate. So it is the low density and poor quality film is made up of. Here good quality film is done. Then we have seen okay, last time up to this point we have covered. Now we are going to see the next. So CVD process we are going to see. So see here that a low pressure chemical vapor deposition system is shown in figure. So from the top and bottom there is a heating elements are there, and in the left and right side that the reactants gases are insert, and here the vacuum is outlet. So in between that chamber that reaction take place, and here the vapors are there. So all CVD systems consist of the following three subsystems. So gas delivery to the chamber, gas removal from the chamber, and vacuum system or exhaust and a heat source. Okay. So all CVD systems consist of the following three subsystems: gas delivery to the chamber, gas removal from the chamber, and the heat source. Okay. So that are shown in a figure. Then next, let us see what the steps of the CVD process are as follows. So the substrate is placed inside the actor. Okay. So substrate is placed inside the actor. So the pressure and temperature are set to the programmed set points. The pressure and temperatures are set to programmed set points. Then select gases and inert gases are introduced into the chamber. Okay, the substrate is placed inside the actor. The pressure and temperatures are set to the programmed set point. Then select gases and and insert gases are introduced into the chamber. So these gases travel to the substrate surface. Then next step, the chamber and substrate temperatures cause the gas molecules react chemically with each other and or the substrate surface. So these reactions form a solid thin film that adheres to the vapor surface. This reaction is referred to as absorption. Okay. The gaseous byproducts are produced by the chemical reaction at the substrate. These byproducts are expected from the vapor surface and vented from the reaction chamber. So the resulting film's thickness is dependent on various process parameters such as pressure. So temperature and the reactants concentration as indicated by the graphic. Some CVD systems are similar to oxidation furnace, a chamber with an input, exhaust and heating elements. Okay, so let us see again the steps of CVD process. The substrate is placed inside the actor. The pressure and temperature are set to the programmed set point. So in that vacuum we are creating the pressure and temperature. Then select gas reactant and insert gases are introduced into the chamber. So which type of the gases we are going to select as well as introduced into the chamber. So these gases travel to the substrate surface first of all. Then the chamber and substrate temperature causes gas molecule reacts chemically with each other, okay, or the substrate surface. These reactions form a solid thin film that adhere to the vapor surface. So these reactions is referred to as adhesive. Okay. So in that chamber, either due to the temperature, gas molecules react with each other or the substrate surface, and due to that reaction, solid thin film is created, and that is adheres to the vapor surface. So this reaction is referred to as the adsorption. So gases byproducts are produced by the chemical reactions at the substrate. So these byproducts are expelled from the vapor surface and vented from the reaction chamber. So the resulting films, so these are the steps involved in the CVD process. So the resulting film's thickness is dependent on various process parameters such as pressure, temperature and the reactant concentration. As indicated by the graphic, some CVD systems are similar to oxidation furnace. So chamber with an input, exhaust and heating elements. Okay. So that whatever the model is used, that are maybe the similar for the oxidation furnace. So these are the steps involved in a CVD process. Then which are the types of chemical vapor depositions? So we have seen the CVD in the two types, homogeneous and heterogeneous. Okay, so that gas reaction and the surface reaction. Then we have seen that what is mean by exactly CVD. Then what are the steps followed in the process. Then next is the types of chemical vapor deposition. So there are many different types of chemical vapor deposition systems, each employing different methods in order to adhesive a high quality film. there are many different types of chemical vapor deposition systems. So each employing different methods in order to achieve a high quality film. So the important distinctions between the different CVD techniques are the amount of pressure required in the reaction chamber and the energy source. So the an atmospheric pressure chemical vapor deposition, so that is APCVD system, uses atmospheric pressure or 1 atm in the reaction chamber. Then second, a low pressure CVD, that is LPCVD system, uses a vacuum pump to reduce the pressure inside the reaction chamber, so to a pressure less than 1 atm. Okay. So second type is the low pressure CVD, that is LPCVD system, uses a vacuum pump to reduce the pressure inside the reaction chamber to a pressure less than 1 atm. Then plasma enhanced CVD, so that is PECVD, so also uses a low pressure chamber. So however, a plasma is introduced to provide higher deposition rates at lower temperatures than a LPCVD system. Okay. So plasma enhanced CVD also uses a low pressure chamber. However, a plasma is introduced to provide higher deposition rates at lower temperatures than a LPCVD system. The next is the high density PECVD. Okay, high density PECVD uses a magnetic field to increase the density of the plasma, thus further increasing the rate of deposition compared to a LPCVD. Uses a magnetic field to increase the density of the plasma, thus further increasing the rate of deposition compared to a LPCVD. Okay. So there are here 4 types we have seen: an atmospheric pressure chemical vapor deposition, then a low pressure CVD system, that is LPCVD, then plasma enhanced CVD, so PECVD, then high density PECVD, that is plasma enhanced chemical vapor deposition. Okay. Then let us see the plasma enhanced CVD, that is PECVD systems. See here. So what is inside this? So here the gas inlet from the topmost side and pump here. Okay. So the shower head is here and the plasma is here. So heater at the bottom side, and this is the substrate. So plasma enhanced CVD, that is PECVD, also uses a low pressure chamber. However, a plasma is introduced to provide higher deposition rates at lower temperatures than a LPCVD system. Plasma enhanced CVD also uses a low pressure chamber. However, a plasma is introduced to provide higher deposition rates at lower temperatures than a LPCVD system. Okay, so plasma enhanced CVD systems. Okay, so one side the gas inlet, then pump is here, here heater is used, then it is the substrate, over that the plasma, and from this gas inlet this is the shower head. So there are the reactions between these, okay, which is the low pressure chamber. Then CVD systems for the microsystem. So one side it is LPCVD and right side PECVD is shown. Okay, low pressure chemical vapor deposition and that the plasma enhanced chemical vapor deposition. So the two most commonly used CVD systems for MEMS fabrications are LPCVD and PECVD. Okay, the two most commonly used CVD systems for MEMS fabrications are LPCVD and PECVD. So the LPCVD, that is low pressure CVD, and PECVD, that is plasma enhanced CVD. So both CVD processes require a vacuum to remove the atmospheric gases prior to introducing the reactant and inert process gases. So LPCVD systems operate at temperatures higher than the 600 degrees Celsius, and PECVD systems operate at lower temperatures down to the 300 degrees Celsius. Okay, LPCVD and PECVD both are the CVD process requires a vacuum to remove the atmospheric gases prior to introducing the reactant and inert process gases. Okay, so LPCVD operate at the temperature higher than the 600 degrees Celsius and PECVD will operate at the lower temperature down to the 300 degrees Celsius. So a plasma is used to provide more energy to the reactant gas molecules. Okay, a plasma is used to provide more energy to the reactant gas molecules. Okay, so LPCVD and PECVD. Okay, so both are used in a MEMS fabrications. So the both are having that the chamber like that the systems, but both having that the different temperature. Okay, which will operate on a different temperature. One is the higher than the 600 degrees Celsius and one is the down than to the 300 degrees Celsius. Then the different operating temperatures can affect the quality of the thin films. Okay, so deposit as well as applications. Okay, so the different operating temperatures can affect the quality of the thin film deposited as well as applications. So the higher temperature of LPCVD produces layers with excellent uniformity of thickness and material characteristics. However, the higher temperatures result in a slow deposition rate and can be too high for certain films already deposited on the substrate. So higher temperature of LPCVD produces layers with excellent uniformity of the thickness and material characteristics. So however, the higher temperatures result in a slow deposition rate and can be too high for certain films already deposited on the substrate. So PECVD operates at a lower temperature, that is down to 300 degrees Celsius. However, the quality of the films tends to be inferior to process running at the high temperature. Okay, means maybe there is a combination of the two layers which will operate on that the different temperatures. So LPCVD can batch process, meaning it can process at least 25 vapors at a time. Okay, so it is also used exclusively when a film needs to be deposited on both sides of the vapors. But for in a PECVD, you can only deposit a film on one side of the vapor and on just 1 to 4 vapors at a time. Okay, then LPCVD is used to deposit phosphosilicate glass, that is PSG, phosphorus doped polysilicon and silicon nitrate. And PECVD is also used for silicon nitrate, but it's primarily used for films or vapors that contain layers of film that cannot withstand the high temperatures of the LPCVD system. So these contents again we are going to see in the next session also. So just have a look on what we have completed in this session. So we have started with the CVD process. Then we have seen the what are the steps are used in a CVD process. Then we have seen the types of CVD. Then we have seen the plasma enhanced CVD system. Then two systems which are mostly used in microsystem that we have seen, LPCVD and PECVD, and what are the things between that the two types that we have covered here. Again, this we are going to see in the next session. Thank you.